Anybody ever feel like this in the middle of the night or in the morning when they don't want to quite get out of bed yet? My need to sleep is less than or greater than my need to pee. Got the little squirrel guy down there saying, should I stay or should I go now? Get a little inequality humor there. Okay, Module 9, Note U, we are looking at inverse functions. We're going to do a quick review of functions at the very beginning, and then we're going to talk about one-to-one functions, which will lead us into inverse functions. Now, if we look at these first 5 examples, they want us to determine whether each of the following relations is a function. Now, most of us probably remember that if we're looking at whether a relation is a function or not, we're really trying to determine whether or not that x value repeats itself if it's paired with more than one y value. So if we check out this first one, we have the points 1, 3, 0, 4, and negative 2, 7. Looks golden to me. So this first one, yes, it is a function. Now my next one, I have 1, 3, 0, 4, negative 2, 7, and 0, 5. Where's my problem at? 0, 4, and 0, 5. That 0 is paired with 4, and then it's also paired with that 5. My x value repeated, so this is not a function. Now notice 3, 4, and 5 are not a list of points. We've got an actual equation here. We've got y equals x squared minus 4x plus 3. What shape do we know this graph is going to take? Hint, it's degree 2. It's quadratic. So we know that it's going to be a parabola and it's going to open up since it's positive x squared. Is a parabola a function? Yes, it is. It passes my vertical line test. Now, the next one, anybody remember what x squared plus y squared equals 1 looks like? What's that equation, the graph of? Think back to the very beginning of the semester. It's a circle centered at 0, 0. A circle is going to fail the vertical line test. It touches in 2 different places. That x value repeats, so this is not a function. And then my last one is y equals 2x minus 4. This is that classic y equals mx plus b. Slope of 2, y-intercept at negative 4. This is definitely going to pass my vertical line test, so yes, it is a function. So remember that if we want to define a function, what a function truly is a relation for which each input value, each x value, is paired with exactly one output value, each y value. So let's write that out. Define function, it is a relation for which each input value, and generally speaking our input value is x, the variable could certainly change though, is paired with exactly one output value. Output value, and typically that output value is our y. Okay, so you really want to think of it having that pair. X is paired with a y. Okay, now what is the inverse of a relation? The inverse of a relation is turning the pairing around. So we are going to flip-flop or switch our x and our y values, our input and our output values. Okay, so think back to some of the examples we just saw. We want to figure out what are the inverses of each of the relations of those functions on slide 1. Okay, so we have 1, 3, 0, 4, negative 2, 7. What is my inverse? I am going to reverse that pairing. I'm switching my x's and my y's. So I would have 3, 1, 4, 0, and 7, negative 2. This would be my inverse. Now, let's think about this inverse we just came up with. Is it also a function? Yeah, it is, because each of my new input values is paired with exactly one output values. So this is also a function. All right, let's find the inverse of y equals x squared minus 4x plus 3. We're going to switch our x's and our y's. So we're going to have x equals y squared minus 4y plus 3. So where I saw y's, I'm going to write x's, and where I saw x's, I'm going to write y's. Now, from a visual standpoint, when I take the inverse, it's essentially going to turn this parabola on its side. Okay? This would fail my vertical line test, so this would not be a function. Okay, and now that last one, y equals 2x minus 4, again, we're going to switch our x's and our y's, so we get x equals 2y minus 4. Okay, and if we think about a line, if I switch my x and y values in a line, I'm still going to have a line. So this would still be a function. Okay. Now, a function that has a different output for any input is called one-to-one, and it has an inverse function. Okay, so essentially what this means is that if its original function is if the original relation is a function and I find its inverse and it's still a function, then we call it a one-to-one function. Okay, we can use what's called the horizontal line test to determine whether a function's one-to-one. Sound familiar? We've got a vertical line test. Now we also have a horizontal line test. So here's the deal. If we want to determine if something is just a function, we're going to use the vertical line test. The vertical line test can tell us if it is a function or not. The horizontal and vertical line test together can tell me if it's one-to-one. Okay. Couple things to make note of so far. Okay. When we talk about functions and their inverses, we're going to find that not every function has an inverse. And we're going to find that all one-to-one functions do have inverses. So that's a couple little side notes to be aware of. Okay. We want to decide if g of x equals x cubed minus 3x squared minus 2x plus 4 is a one-to-one function. Okay. This is a cubic graph, so we know that it's going to have that snake shape to it. Okay. Now, previously we would have just asked, is this a function? And we would have said yes, because it would pass the vertical line test. Okay. So it is a function. Now we want to know, is it a one-to-one function? Now we're going to use that horizontal line test. if I draw a horizontal line, it passes through more than once. It fails the horizontal line test, so this is not a one-to-one function. Let's look at f of x equals the absolute value of x next. Okay, we know based on our parent functions that this has a V shape to it. It would pass my vertical line test, so I do know that it's a function. But if I use the horizontal line test, it is passing more than once, so it is not one-to-one. Okay. And then my last one is h of x equals the square root of x plus 2. Now, we discussed the parent function of the square root of x previously, although it might not be fresh in everybody's mind. But it essentially looks like the top half of a sideways parabola. And that x plus 2 on the inside of my square root, on the inside of that grouping symbol, would have moved that graph to the left 2. So that's a little previous knowledge. But knowing this generic shape, I know that this would pass my vertical line test, and it's going to pass my horizontal line test. So this is a one-to-one function. Knowing those generic shapes is a very valuable skill to have, but you could, if you really needed to, look back in your calculator at the shapes of these graphs. Okay, let's talk function notation. So we previously discussed that sometimes instead of using y, we use f of x. So we have a pairing here. It shows it in the chart. We have x and f of x. So these are ordered pairs -2, 4, 0, 6, and 1, 7. If we want to find the inverse here, we are still switching our pairing. Our x and y are still switching. But notice this notation. We have inverse notation here. When I write the y equals the inverse of f of x, it almost looks like I've got a little exponent of -1 squished between that f and that x in parentheses. But this is not an exponent. It's just in the superscript position. This is my inverse notation in function notation. Okay, so this notation right here is my fancy inverse notation. Okay, so keeping that in mind, if we know that f is 1-to-1 and f of -3 equals 2, we want to find the inverse of f of 2. So we are switching that pairing. So previously, I had the pairing -3, 2, because f of -3 equaled 2. If I reverse that pairing now, my inverse is going to give me an output value of -3. Now, part B is in here to make sure you understand the placement of this function notation, okay? Notice the placement here. That -1 in my superscript is not between my f and my input. This does not mean inverse in this case. This means an exponent of -1, okay? An exponent of -1, think back to those negative exponents, really tells you to find the reciprocal. So this is saying what's the reciprocal of f of -3? What's the reciprocal of 2? It is 1/2. So let's make ourselves a little note here. Okay. Notice the placement of -1. Okay. When I have it in the superscript between my f and my input, this means inverse. But when I have it in the exponent position, this means I'm finding my reciprocal. So be very aware of that placement, especially in terms of how you're writing it on your own paper. Okay, now we have that f is 1 to 1, and the inverse of f of 5 equals 7. We want to find f of 7. So again, we're flip-flopping, we're switching that pairing, we're switching our x and our y. So f of 7 would equal 5. All right, we're looking at this from more of a visual standpoint this time, okay? I have a graph, it's a linear graph, and they want us to find f of 0, just like we always have. This means that when x is 0, what is my output value? So I'm going to 0 on my graph, an x value of 0 on my graph. I'm going to follow it up, and I get that it has a y value of 3. So f of 0 equals 3, excuse me. Nothing new there. We've done those kinds of problems previously. Now this one says f of x equals 0. So this is telling me when y equals 0, what is the x value? Okay, so if my y is 0 and I follow it over to my graph to my x value, my x is going to equal 2. Okay. Now the next two examples get into that function notation. This one says, okay, what's the inverse of f of 0? So now we're flip-flopping that pairing. It is going to be 2. And now they want to know what is the inverse of f, or what's the x value when the inverse of f of x equals 0? And the answer here would be 3. So think about this. I had the 0.03 from the very first question. When I find its inverse, it's going to give me 3, 0. In the second question, I had the 0.20. When I find its inverse, I'm going to have 0, 2. Okay, so really the first and fourth part and the second and third part were paired up. Okay, we're going to pause there. That's an appropriate place because the next part of this section is going to still focus on inverses, but we're going to look at finding them algebraically instead. So we'll see you in that next video in just a minute.